The code consists of about 1,000 lines of C, although we use a little bit of Python for graphing. When the code is actually run, it creates a path in world space that the snake is going to follow. And then what we do is we go down, and at each point on the path, we figure out what the curvature is along that point of the path, and that makes the translation into joint space. So it lays out this curve along this path of the angle that a servo has to be at that point of the path in order to make its corresponding nodes also lie along the path. In order to make the snake actually move, we then drag the head up manually and recompute everything, basically dragging backwards. So when I run this, the snake progresses forward, and each of the servos, the 15 servos are represented by 15 vertical lines, they move forward along the joint space path. When it gets to the end of the path, this is slightly interactive. It wants to decide whether it wants to turn left, right, or go straight. We actually have a joystick, and by moving it, say, to the left, and I'll hit enter, it computes a new path, a new segment of the path that's centered around a certain point. So it tries to curve to the left, and it computes a sine wave around that in order for the snake to locomote, and then it follows that path until it gets to the end. And so by doing this, it's able to continually get input from the user and compute a new path. The path is very smooth, although the actual path that the snake follows is sinusoidal about it. That's about